then you can start.
Okay.
Okay, we are live.
Okay, good morning, grade 5s. I hope you guys had a wonderful weekend. I know I did, and I really missed you. I hope you guys still remember what you did last week. And remember, I said you guys should practice. I hope you practiced. Okay, it's Memmaluleke for those of you that are joining us today. And then I am taking you for maths. We started 2 weeks back with maths, and we've covered 3 topics so far. We are still on common fractions. So if this is your first day to join us, you haven't lost much. So we are continuing with counting, comparing, and ordering fractions. If you still remember, we did equivalent fractions, and then the last lesson was speaking about how do we find equivalent fractions. And then I showed you how to use the fraction wall, and then there were kids that were also really interactive and they were able to answer. So today we moved on to teams. Unfortunately, you won't have the option to call in like you guys used to do, or to be unmuted so that you can talk. So the only way of communication from now onwards is through the chat. I really hope your parents can show you how to chat. So what I'm going to do is I'm going to give you a question, if there's a question, and then I'll wait for you guys to respond, and then I'll go to the chat and see what you guys answered. And then thereafter, I will read some of the answers like we usually do. So the only thing that we're not going to be able to do today is for you to be unmuted and to talk. Yes, I also missed that, but yeah, I hope you guys are always on time, because now, unfortunately, I cannot see who is here and who is not here. Remember, I will be able to see who is late and who is not late. So I hope the Zamos and the Pels and the Praises and the Leletus are here. So let's go straight to the lesson. So we are counting, comparing, and ordering fractions. By the end of the lesson, you'll be able to count in fractions, and you're also going to be able to compare fractions using a fraction wall. You're also going to be able to compare fractions without using a fraction wall. And then the last thing that you're going to be able to do is to order fractions. So we are still on fractions. We'll be on fractions up until Thursday, and then we'll start on a new topic. So about counting fractions, remember the same way that we count whole numbers, we've counted the whole numbers. The same way that we count whole numbers, that's the same way that we also count fractions. So whole numbers, I spoke about a number line. So also the fractions, we can find them in a number line. So fractions have a specific place on a number line, and then we can use a number line or a number chain to count in fractions. When we're counting, for example, in halves, we have to add half each time. I'm going to show you. And then when we count in quarters, we have to add quarters and so on. So after the whole number, that is 3/3 or 4/3, you can continue counting in improper fractions, or you can count in mixed numbers. So what do I mean by this statement? I'll read the statement again. After the whole number, remember we said a whole number is when the denominator and the numerator are the same. So our whole numbers, they start from 2/2, which is 2 halves, or 3/3, 4/4, 5/5 going forward. So after the whole number, when we are counting, you have a choice. Unless your teacher specifies, you can count in improper fraction. So say, for example, 3/3, then the next one will be 4/3, and then followed by 5/3, followed by 6/3, 7/3, and so forth. That is counting in improper fractions. For those of you that were not here when we did the definition of improper fractions, I'll just remind you, and also for those that have forgotten, because with maths, we have to always constantly remind, because we're doing new things every day. So we say that an improper fraction, if you can still remember, some of you, we also called it an abuse fraction. Why did you say it's an abuse fraction? Remember, we also say that a fraction is made of a numerator and a denominator. So in an improper fraction, the numerator is bigger than the denominator. And then I gave you guys an example of a father carrying a son on the shoulders. I said it's very normal when we see a father carrying a son, a 2-year-old son, 3-year-old son on his shoulders. But then it's going to be abuse, or it's going to be improper if we see a 3-year-old son carrying the father on the shoulders. So that is how you have to think about the improper fraction. So I remember on Friday, some people, they also gave me back that definition, so it helps you to remember. So remember, improper fraction is the abuse fraction. And then how do we see the abuse fraction? We see the numerator being bigger than the denominator. And then so that is counting in improper fractions. Or we can count in mixed numbers. And then we said we call it a mixed number because it has a whole number and a fraction. So after 3/3, you can then continue to say 1 and 1/3. I'll show you now. So the examples of counting in fractions, I gave you the first one, which is we are counting in halves. So if we look here, this is a number line, very important. It helps you to see the fractions. So our number line always starts from 0, and then we have our many holes now because this is the first whole, and then we can also identify the fifth whole number. So how does this work? So from 0 we go to half, and then after half, if I say half plus half, I get 1, and then from 1 I add another half. Remember, we are counting in halves, so if I add a half to a 1, I get 1.5. And then if I add another half to 1.5, I'm going to get 2 wholes. So you can either say 2 wholes or you can say 4/2. How do we get this 4/2? All right. So let's start from here. So it's 0 and then 1/2 plus, if I say 1/2 plus 1/2, I get 2 halves or 2/2. And then if I say 2/2 plus 1/2, I get 3/2, which is also the same as 1.5. I will show you on another lesson how to convert from improper to mixed number. So don't worry if you don't know how to convert. For now, you can just see counting because we know we've been counting in halves since we were you guys were in grade R or grade 1. So it's 0, half, 1, and then 1.5, and then it's 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6. So you see, you can actually rhyme it. So then it becomes easier for you. And then we have a question there. The question is, which fraction will come after 1.5? So if we're listening already, I've given you the answer. So after 1.5, if I say 1.5 plus a half, so those 2 halves are going to add together to give us 1 whole. For those that maybe joined us today and they don't know what a whole is, we can simply explain a whole as a full number. Think of an orange. If I give you an orange that is not cut, that is not peeled, that is a full orange. But then if I take that orange and take my knife and cut it in half, now I have a half. So when you talk about a full, it's untouched, it's a whole, it's untouched, it's full. So it's not like a fraction. And then we say the fraction, it's part of a whole. So a whole can be divided into many fractions. And then number B says, how else can we write 1 whole when we are counting in halves? So if we check here, we have 0, and then we have half, and then we have 1 whole. How else can we write 1 whole? Okay, with this one, if you guys are able to access the chart, I would like you guys to write the answer for that one. How else can we write one whole when we are counting in halves. So already I've said it's 1, but how else can we write it? What's the other way of writing it? Okay, I'm sure you have said we write one whole as 2 over 2. And then number C, if you say 2 over 2, you are right. Number C says, after 5 wholes, which one is the next fraction? So which is the next fraction after 5 wholes? So here is 5 wholes, and then after 5 wholes, if you say that the answer is 5.5, you are right. So after 5 wholes, the next fraction will be 5.5. And then the last question on counting in half says there are 2 ways of writing it, and these are, what are the 2 ways of writing 5.5? So we can either write 5.5 in as an improper fraction, or we can write it as a mixed number. So as a mixed number, it's 5.5, and then as an improper fraction, it will be 11 over 2. It will be 11 over 2. And then now we are looking at counting in quarters. So counting in quarters, so this means that now our whole, remember in counting in halves, our whole was divided into 2. So now counting in quarters, it means that our whole is now divided into 4. So a quarter means 4. So when we count in quarters, before we can reach one whole, we have to count at least 1, 2, 3, and then the fourth time is going to be a whole. Unlike in a half, where we count 1 and the second time it's a whole, in quarters, when we count the fourth time, that is when we're going to have a whole. And then in the example above, how else will we write one whole when we are counting in quarters? So we start counting from here. 0, 1 quarter, 2 quarters, 3 quarters, and then 4 quarters. You are right. If you said 4 quarters, you are right. 4 quarters. And then if we want to continue counting in quarters without putting the mixed number, then we'll say 5 quarters, 6 quarters, 7 quarters, and then 8 quarters. And then after 8 quarters, then we have 9 quarters. Or you can count as 1 whole, 1 and a quarter, 1 and 2 quarters, 1 and 3 quarters, 1 and 4 quarters, and 1 and 5 quarters. So 1 and 5 quarters will give us 2 and a quarter. So either way, we can count in 2 ways. And then which fraction will be after 1 whole? So after 1 whole, we've already said it's 1 and a quarter or 5 quarters. And then number C says, how do we write the fraction that comes after 1 whole? So the fraction that comes after 1 whole, we can write it as 5 over 4, or we write it as 1 and 1 quarter. And then, so this is, if you see this number line, how are we counting? What fractions are we counting in this example? Are we counting in this example? You see, I didn't start from 0, so now the standard is going a little bit higher. I didn't start from 0 to say 0. No, I didn't do that. So how are we counting? In what fraction are we counting? So if you get a question like this in an assessment, how are you going to see? Because here we see mixed numbers. How are we going to see which fractions we are counting in? I'll tell you. So here is a denominator, and our denominator is 5. So what this simple means is we are counting in fifths. So the first one here is 1 and 1 over 5. And then the second one is 1 and 2 over 5. And then the third one is 1 and 3 over 5, followed by 1 and 4 over 5. I'm sure from here you can count on. And then let's go to the questions. Which fraction comes before 1 and 1 over 5? So here, if I had this part, which fraction will be here? Which fraction will be here? If you said 1 whole, you are right. If you said 5 over 5, you are also right. And then number B, which fraction comes after this one? Which fraction comes after 1 and 4 over 5? So the fraction that comes after 1 and 4 over 5 is 1 and 5 over 5, but then we're going to say is 2 wholes. We say is 2 wholes, and then when we are done with the lesson, you see why there is blank spaces. I want you to go and do your own number line using the same fractions, and then you fill in. So that is your homework for today. You fill in I didn't fill it in for you because I want you to go back and practice. And then number C says, which fraction comes before 3 wholes and 1 over 5? So which fraction comes before this one? I'm not going to give you an answer now. Remember the homework. So you will say which fraction comes before 3 and 1 over 5. And then number D, how can we write 1 and 1 over 5 as an improper fraction? Remember, we said that an improper fraction, the numerator is bigger than the denominator. So how can we write 1 and 1 over 5 as an improper fraction? So we can write 1 and 1 over 5 as an improper fraction. Remember, before 1 and 1 over 5, we have 5 over 5. So which means that now we just add 1 and it becomes 6 over 5. If you had already said that, you are right. So that's it about counting in fractions. You see how easy it is. So you just add, if we're counting in halves, you just add the half. If we're counting in quarters, you just add the quarters. If we're counting in thirds, you just add a third. And then now we look at comparing fractions. So we're going to compare fractions. So when we compare fractions, we want to see which fraction is bigger and which fraction is smaller. So we want to see which fraction is bigger and which fraction is smaller. That's why we compare. For example, comparison, we did comparison, we compared in whole numbers, and then we checked which number is bigger and which one is smaller. So the same knowledge that you gained when we compared numbers is the same one that you're going to use when we are comparing fractions. So it is easier to compare fractions that have the same denominator because you will then check for the numerator to see which one is bigger or smaller. For example, I will repeat. It is easier to check fractions with the same denominators. So here the denominator is 5 and there the denominator is also 5. So what we simply do, we just have to check the numerators. So what do these fractions mean, or what do they entail? Now, my maluleke bought a cake, 2 cakes actually, same size of cakes. And then the first cake is divided into 5, right? No, let's use it, still the same cake. So we cut this cake into 5 equal pieces. And then my maluleke takes 4 pieces. I'm the bigger one, right? So when I don't eat much because you are the smaller one, I'm joking. So Maluleke takes 4 pieces out of 5, and then you take 1 piece out of 5. Who's going to get the bigger piece? Obviously, Maluleke has 4 pieces, so this means that I have the bigger cake. So if the denominator is the same, or if the cake is cut into the same number of pieces, then it is easier to compare because you only check the numerator. Remember, the numerator is the top number. In cases where the denominators are different, so you'll find that here the denominator is 5 and the denominator is 10. How then are we going to compare? So in cases where the denominators are different, you have to use diagrams, you have to use a fractional, you can also use a number line. In term 3, when you do fractions again, you'll be able to use what I call an abstract method. So this is a method without using concrete manipulatives. So you won't use a diagram, you won't use a fractional, you won't use a number line, you're going to calculate them. But now I want you to understand that's why we're going to use diagrams, we're going to use a fractional and also a number line. Okay, so we start with the number line. Use a number line to compare fractions. So what I like about this number line, or let me say these pieces of cakes or these cakes, they are cut into the same, or they are the same size. So you can see the whole is the same. 0 to 1 is the same. Can you see that? But then what is different with these cakes is they are cut into different pieces. So the first one is cut only into 2 pieces. So it's cut into halves. So obviously the first one, if we are sharing it with 2, we're going to get big pieces. And then the second one is cut into thirds, which means now instead of getting that big piece of half, now you get a little bit smaller piece, but it's better. Now let's look at the fourth one. The third one is cut into quarters. So which means this now it's still the same size of cake, is cut into 4 pieces. You see how small the pieces are getting now? It's not fair. And then the next one is cut into 6. So still the same size of cake, but now it's cut into 6. So now remember on the first one you got this big piece, and now you're going to get this small piece. And then the last one, the last number line that I gave you, this same size of cake is cut into 12 pieces. So check how small the pieces are. So now instead of getting this big one, you are now going to get this small one. All right. And then now using the number line, we compare the fraction. And the question is, I would like you guys to go back to the questions. It's very important because I can talk and talk and talk, but if you guys do not practice it and if you don't do it, it's not going to stick. And then, so which fraction is bigger between 1/2 and 1/3? Now, before I take you to the number line again, I want you to think if you were at home and I didn't show you the number line. Be honest, what was your answer going to be? You see 1/2 there, it's a 2, and then you see a 3 there. Where you're not going to automatically say because 3 is bigger than 2, and then you're going to say that 1/3 is bigger. So we call that misconceptions. So that is a misconception that most learners have when it comes to fractions. So if you see that the denominator is big and then here the denominator is small, and then someone might say, no ma'am, 1/3 is bigger because I can see that 3 is bigger. But unfortunately not. It doesn't work that way with fractions. So as I've shown you already, this is 1/2, check how big a piece 1/2 is. And then this is 1/3, check how small 1/3 is. So this means that between 1/2 and 1/3, the fraction that is bigger is 1/2. Yes, so the smaller the denominator, the bigger the, I've given it away. Okay, let's check. Number B, we are comparing 1/4 and 1/6. So please do not say, ma'am, 1/6 is bigger because 6 is bigger than 4. In whole numbers, yes, 6 is bigger than 4, but in fractions, 6, if it's a denominator, 6 is not bigger than 4. So we come to our number line here, and then we check 1/6. Okay, from 1/6, the piece is this one up until here. And then whoever got a 1/4, they got a piece that is from here to there. So can you see that whoever got a 1/4 got a bigger piece than the one who got a sixth. So this means that 1/4 is bigger than 1/6. I hope you can understand that. It means that 1/4 is bigger than 1/6. And I have proof. You can see the proof, right? From a sixth is 0 up until there, and then a quarter is there up until there. So a quarter is bigger than 1/6. Do you notice that if the numerator is 1, the biggest fraction is the one with the smallest denominator, right? So these fraction facts that you have to know. So if the denominators are the same, we only look at the numerators. So if I'm comparing 1/10 and 2/10, 2/10 is bigger because the cake is divided into the same equal parts. And then if the denominators are different, but the numerator is 1, I want you to listen, grade 5. If the denominators are different and the numerator is 1, the smaller the denominator, the bigger the fraction. Now we move on. Because it's maths, we cannot just take one thing and say, yes, now I know all the fractions. You're going to get a different sum. What if the numerator is not 1? So you see, I'm bringing it now. I first gave you, what if the numerator is 1? Okay, we check the smaller the denominator, the bigger the fraction. Then I'm saying, what if the numerator is not 1 and the denominators are different, and the denominators are different? It takes us to the next slide. Okay, so now we are comparing fractions with different denominators and different numerators using what? Using diagrams. Remember, I said we're going to use diagrams, we're going to use a fraction wall, we're going to use a number line. So now I gave you the fractions, and I want you guys to check. These circles are the same size. Can you see? So we can take these circles as a cake. I don't know which one is your favorite cake. I love red velvet with all my heart. Maybe also red velvet is your favorite cake, or chocolate, or vanilla. Okay, so I love red velvet. So these cakes are divided. They are the same size of cake, but then they are divided into different pieces. The first cake is divided into 3 equal pieces. Remember, it's only a fraction if it's divided into equal parts, so all the parts should be equal for us to call it a fraction. So we cannot have one part being small and the other one this big. Then we cannot call it a fraction. It only becomes a fraction if it's divided equally into the same pieces. Okay, so the first one, the whole is divided into 3 equal parts. And then how many are we talking about? 2 is shaded. So we say this fraction is 2/3. And then the second one is divided into 1, 2, 3, 4, 5, 6 into 6 equal parts. And then how many are we talking about? When I say how many, what is the numerator? So we find the numerator by seeing how many is shaded or how much is shaded. So in this case, how much is shaded? 1, 2, 3. So this means that this fraction is 3/6. And then without really having to work it out, we can just use our eyes to see. So which pieces are bigger? Can you see how much space is not shaded here? Can you see that this fraction, this one, it's almost, the whole circle is almost shaded. So then this one is bigger than this one, because here half is shaded and half is not shaded. But here, if I cut my circle here, can you see where my half is? So this means that more than half is shaded. Then we'll say 2/3 is bigger than 3/6. And then remember the crocodile that I spoke about. We said that the crocodile only eats the bigger fraction or the bigger number. So our mouth of the crocodile is like this, only eats the bigger one. And then the next one here, still the same size of cake. And then this one is divided into 5. It becomes our denominator. Maybe if you were struggling on how do we get our denominator. So we check into how many pieces is the fraction divided, is the shape divided. So this one is cut into 5 equal parts and it becomes our denominator. And then how many is shaded? 1, 2, 3 is shaded. And then we come this side, it's cut into 10 and how many is shaded? 1, 2, 3, 4 is shaded. But which one is shaded? Which circle has a bigger part that is shaded? So we cannot say because this one is divided into 10 is the bigger one. No, we check which one has the bigger part that is shaded. So 3/5 is the biggest one. And then let's do the last one, and these ones you guys can look at them by yourselves. Okay, so here still the same size of circle, and then this one is cut into 4, this one is cut into 8, and then here only 1/4 is shaded, and then on the 8 you can see there is a quarter shaded and more. These 1, 2 make a quarter and 1/8 more. So this means that 3/8 is bigger than 1/4. So that is how we use the diagrams to compare fractions. And then maybe let me take a pause and see if there are questions, because I'm not able to see what is typed here. Did we have any questions?
No, ma'am.
Not. Okay. All right. So it means I'll continue. Okay, so now we used circles, and now we are using rectangles to compare. So you see the diagrams, you can use any diagram as long as it's cut properly. So these ones, I love them because we can see the same size of, we can say it's chocolate. The same size of chocolate, but then it's cut into different pieces. So the first one, same size but it's cut into 5, and then same size but it's cut into 15. So the first one is 2/5, and then the next one is 6/15. So they are the same. So you're not going to say 6/15 because 6 is bigger and 15 is bigger. No, we have to do the right comparison. And then the next one, still same size of chocolate, and then the first one is cut into thirds and the next one is cut into 12ths. So we can see the 2/3 and the 12ths, then the 10/12ths. So which one is bigger? 10/12ths is bigger because the line of 2/3 end here, and then the line of 10/12ths end here. So this, the 10/12ths is bigger. And then we come to this one. We are comparing 2/3 and 3/6. I just want to show you grade 5 that it doesn't necessarily, when the numerator and the denominator are bigger than the other fraction, it does not always necessarily mean that that fraction is bigger, depending on which fraction we are comparing it to. Okay, so but in this case, we have 2/3, and then there we have 3/6. So you can't say 3/6 is bigger because 3 is big and 6 is small. It doesn't work that way. So in this case, we can see where the line for 2/3 ends and where the line for 3/6 ends. So this makes 2/3 to be bigger than 3/6. And then the next one, we have 5ths there, and then 3/5 is shaded, and then there 4/10 is shaded, and then which one is bigger? So we check the line for 3/5 is longer than for 4/10. So that is how we use the diagrams to compare. And then here we have a quarter. So you see, same size from here to here is the same. A quarter, and we are comparing it to 12ths. So how many 12ths? To 4/12. So this is where the line for 4/12 ends, and then the one for 1/4 ends. So which one is bigger? 4/12 is bigger than a quarter. And then the last one, how many parts is the first one divided into? Into 5. And then the next one is divided into 10. So we can see where 2 over 5 ends, and then we can see where 8 over 10 ends. So these are called manipulatives. So if you have this, most probably you are not going to get things wrong. And then now we come to comparing using a fraction wall. So this is also part of your homework. I know there's people that will go and view on YouTube. This you can do it at home and then ask your parents to mark it for you. So I already explained how the fractional works, but maybe for those that to watch this and they did not hear how the fractional works. So this is one whole. So every fraction here, it's up to one whole. So we can see on top here is divided into halves, and then here is divided into thirds, and then the next one is divided into quarters, and so on. And then you have to use greater than or less than or equal to compare the fractions below. And how do we compare this? We also did it on Friday last week. So we check, we are comparing 1/2 and 1/10. So do not say 1/10 is bigger because 10 is bigger than 2. Do not say that. We have to have proof. Remember, one of the rules says if your numerator is 1, the smaller the denominator, the bigger the fraction. So where is 1/2? 1/2 starts from here going up until there. This is where 1/2 ends. Can you see that? And then where is 1/10? We come down to tenths, and then we only want 1/10. So 1/10 starts here, and then 1/10 ends there. 1/10 ends there. Can you see that? So which one is bigger between 1/2 that starts here and ends here, and then 1/10 that starts here and ends here? Do you see how we use the fractional? So obviously 1/2 is bigger. That proves my statement that the smaller the denominator, and then the bigger the fraction. And then number B, 1/5. We are comparing between 1/5 and 5/10. So we check where is 1/5. 1/5 is here. And then where is 5/10? So 1/5 is here. And then 5/10, we come to tenths. Here are tenths, and then we have to count 5. So this is 1, 2, 3, 4, 5. So 5/10 the end here, and then 1/5 ends there. Can you see that? So this means that 5/10 is bigger than 1/5. And then number C, we are comparing 5/10 and 2/4. So we come here, we look for the quarters. 2/4 is 1, 2, and then they end here. And then 5/10, we come to the tenths, and then we count 5, 1, 2, 3, 4, 5. And then we come here, we wanted 2/4. Can you see that they're on the same line? So this means that 2/5 and 5/10 are equal. And then the last one, this one is tricky for you. I said 1/2. 1/2 is here. So 1/2 starts from here and 1/2 ends there. And then 6/5. So can we find 6/5 here? Let's look. Using the knowledge that I've already given you, I said that 6/5, it is an improper fraction. So an improper fraction is bigger than 1/2. So this 6/5, it means that in the 6/5, there is 1/2 and extra. So because 5/5 is 1, 2, 3, 4, 5, and then 6/5 will be outside the fractional. So this means that 6/5 is bigger than 1/2. So I would like you to do this activity at home as your homework. And then we come to the last one of ordering fractions. So we can order fractions from smallest to biggest. That is from descending order to or from biggest to smallest, which is ascending order. We spoke about those terms, these terms, and we said descending means from smallest to biggest, and then ascending, because it's the first one. Ascending means from biggest to smallest. Descending means from biggest to smallest, My typing problem there. So descending means from biggest to smallest, because you descend. If you're descending, you're coming down like an aeroplane descending, and then ascending, we are going up. So there is a typing error. Okay, and then when fractions have the same denominator, we look at the numerator to see which fraction is bigger. So for example, I gave you a question there. Order these fractions in ascending order, that is from smallest to biggest. So we have to order them from smallest to biggest. And which fractions do we have? 3 tenths, 7 tenths, 2 tenths, 9 tenths, and 5 tenths. So they have the same denominator. So this means that in ascending order from smallest, the smallest one is 2 tenths, followed by 3 tenths, followed by 5 tenths, followed by 7 tenths, and then the last one is 9 tenths. So the same way that you order numbers, that's the same way that we order fractions. So I hope you understand this one also. Okay, it's easier. These ones, most learners, they always get it right here. And then in cases where the denominator is not the same, we have to use the fraction wall or diagrams to order the fractions. So I chose here to use the diagrams. So we have 1/3, and then we have 4/6, and then we have 3/12, and then we have 3/6, and then we have 5/6. And then from smallest to biggest, the smallest fraction we can see is 3/12, followed by 1/3, followed by 3/6, followed by 4/6, and the last one is 5/6. So the bigger fraction becomes the one that is shaded the most. So if it's shaded the most, it becomes the bigger fraction. So we can use a diagram, but when you come to grade 6, there is a way of doing this without using the diagram and the fractional. But because you guys are still in grade 5, and I mean just last year you were in grade 4, so we want you to understand the concrete part. We want you to understand the practical part before I can tell you that you have to find the highest common denominator and so on. Okay. And then takeaway message. In summary, you can use a fraction to compare different kinds of fractions until you are familiar with many fractions. So you can use a fraction wall to compare different kinds. In a fractional, there's all fractions. There's 2 tenths, there's 3 tenths, there's 4 tenths. Do not just look at the one with the one numerator. So until you are familiar with many fractions, I'll also appeal to you grade 5s. If you can master fractions now in grade 5, when you go to grade 7, grade 8, it's going to be easier for you. In grade 6, you're going to be a master of these fractions. And then tomorrow, we are going to look at addition and subtraction of fractions with the same denominators. So this brings us to the end of our lesson. I hope you guys are here tomorrow. Goodbye.